Hello dear friends, welcome to Gate Academy Global. So before starting today's session, I would like to take the concurrence as well as the feedback from each one of you regarding the quality of video as well as audio. If everything is perfect, just write perfect over the live chat and then we will start the continuation part of the topic which we have been covering in the last topic. Anyways, this is gonna be the third topic, or this is gonna be the third lecture over the series of the engineering mathematics which have started from the vector calculus. So already we had the two lectures just yesterday and day before yesterday, and there I was discussing about the basic concept of the coordinate system. I started with the Cartesian coordinate system in the first video, and once we done with the first video, in second video I was talking about the practical significance of the curl as well as divergence by taking few of the vector fields. Anyways, in the continuation with the last video, I would take few more vector fields, and with the help of those vector fields I will try to understand the basic concept of the divergence as well as curl. Divergence as well as curl. Just wanted to know what about the quality of video as well as audio. If it is perfect, at least I want one reply as a perfect over the live chat. Yes. So let me go into the working board. If you'll recall, in last class what I was discussing, in last class I have taken few of the vector fields. Vector field was taken. Vector fields in Cartesian coordinate system, and by visualizing those vector field, I figure it out what about the divergence of the given vector field and similarly curl of the given vector field. Yes. So I would understand. If you guys have gone through my last video, definitely you would have a little bit practical understanding of divergence as well as curl. Yes. Now I would take few more number of examples and will try to even enlighten the concept of the divergence as well as curl by watching the practical vector field over the 3D space. So let me go ahead by taking few number of more vector fields. Let's take now the vector field which I am going to take in today's class. Let's take, it's gonna be y square of ay cap. So before drawing this vector field over the 3D coordinate system, I would like to ask from each one of you, what do you expect, what would be the value of the divergence and what would be the value of curl for this given vector field? Why I am calling it vector field? Because you can see along with the magnitude even the direction is also been attached. So the student who have gone through my last video probably would be able to figure it out how the y square ay cap would look like in 3D space, and end of the day by visualizing that vector field they would be able to figure it out what about the divergence as well as curl of this vector field. Tell me what about the y square ay cap, what about its divergence, what about its curl? So I need to find out the curl and divergence of this vector field. Now the answer have started coming. The Vijay Kumar says 2y divergence and curl is ... Anyways, the curl is gonna be simply null vector. That means it would be a curl free vector. Anyways, how did I know about it? Obviously, I could have applied the mathematical formula for the divergence as well as I could have applied the mathematical formula of the divergence, and from there I could figure it out each and everything. But as I have been communicating in the last class, yes, the mathematical process is the process through which easily I can get the divergence as well as curl, but I do not exactly understand practically what does it mean by the divergence as well as curl. So what I would do, first at very beginning I would draw y square ay cap over the Cartesian 3D space, and then from there visualizing the each and individual field we'll try to understand at any moment of point over the 3D space whether the vector is trying to sink or source. If it is trying to sink, what does that mean of it? That means the divergence would be negative. Whether it is trying to source, the divergence would be positive, and whether we are getting any rotational force or not. If we are getting the rotational force, what does that mean of it? That means its curl would be a non-zero value, and if we are getting a irrotational field, or if I am not getting any rotational force, its curl would be simply zero. Yes, many of us have started giving the answer, that is 2y ay cap, but still you do not exactly know how the field would look like. Just wanted to ask from each one of you, how many of us are live? The 12 to 11 number of people are live over the live chat. Just wanted to ask from each one of you, would you be able to draw the y square ay cap over the Cartesian coordinate system which I was doing in the last class? Yes or no? If the answer is yes, write yes over the live chat, and if the answer is no, write no over the live chat. What I would do, I would take again the Cartesian coordinate system for the sake of reference. Yes, I have taken a Cartesian coordinate system. So here goes my positive z axis, here goes my positive y axis, and vertically outside from this plane comes my positive x axis, Yes, let me mark them out. Yes, this goes my x axis, this goes my y axis, and this goes my z axis. And the vector field which we had to draw over this Cartesian coordinate system is nothing but y square ay cap. Y square ay cap. What does it mean of it? See, y to the power of 2. The power of y is an even value. That means for the positive as well as negative value of y, the y square would always be positive. And if y square is always positive, that means the direction of this vector field would always be in the direction of positive ay cap. Positive ay cap. Could you understand what I am saying? So what I would do, I would bifurcate into two part. First, I would be focusing over its magnitude, and secondly, I would be focusing over its direction. As the y square would always be a positive value, that means let's take it's a vector. So if we'll talk about its magnitude, that simply equals to of mod of a. Mod of a would be equals to of y square. Yes, that's the first thing, and always the magnitude has to be a positive value, and you can see very well if the y is positive or negative. In both of the cases the magnitude is simply positive. And if we take unit vector in the direction of a vector, which is simply equals to of positive ay cap. Till this moment of point, probably each and everything must be clear to all of us. Yes, sir, RU lecture are also available on PDGD course. We'll see that. Anyways, now what I would be doing, you can see very well, always the direction of the vector field would be in the direction of positive ay cap, whether the y is positive or whether the y is negative. Agreed? This is equally true for positive value of y as well as negative value of y. The direction would always be in the direction of positive ay cap. But yes, the magnitude is going to be decided by y. At 1, the magnitude is going to be 1, yes, throughout. Similarly, at y is equals to minus 1, the magnitude is again going to be 1 throughout. Similarly, at 2, it would become 4, because here the factor which is going to decide my magnitude is y square, and if I keep y is equals to 2, it becomes 4, 3, 9, so on, so forth. What I would be doing, just for the better understanding, I would take the reference of y is equals to 1. What I am saying? I am taking the reference of y is equals to of 1. Somewhere here the y equals to 1 comes. Somewhere here y is equals to of 1 comes. Let's take this is y is equals to 1. Yes. How we can say this is y is equals to 1? This complete vertical line, there is no shifting towards right hand side or left hand side. That means the value of y is constant. And for the time being, if I have taken the value of y is 1 over here, so definitely throughout its vertical length, value of y has to be 1. Similarly, here goes the next one. Anyways, let me copy this out. Here goes y is equals to of 2, and let's take here goes y is equals to of 3. Yes, and towards the left hand side I can take y is equals to of minus 1. Let me copy this out. Here somewhere here goes y is equals to of minus 1. Here goes y is equals to of minus 2, so on and so forth. Yes, my dear friends. Now what I would be doing, at y is equals to 1, may I know what would be the magnitude? The magnitude is simply going to be 1, which we have seen earlier. So the magnitude is simply going to be 1. We can draw over here. The magnitude is simply going to be 1. And as I have been communicating in the last class, the length of this chord or the length of this arrow would be deciding my magnitude. You can see very well over this complete variation in the vertical sense, the length has been taken same. Now if you'll go at y is equals to of 2, what is happening? Still the direction would be in the direction of positive ay cap, but the length would increase from 1 to 4. Yes, there would be a significant change in its length. So let me draw that also. So here it would be like, yes, yes, no. So I would recommend to each one of you, draw this figure neat and clean, this figure neat and clean. And similarly at y is equals to of 3, even it would become more larger, and yes, it would become somewhere 9, or the change in magnitude is exponent in nature in a power of 2, Yes, yes, my dear friends, did you agree what I am saying? Now if I go towards, let me extend this a bit, Here I have taken y is equals to of -1 and y is equals to of -2. Yes, yes, my dear friends. So what I would be doing, even at y is equals to of -1, the magnitude would be +1 and direction would be in the direction of positive ay cap. Let me copy this out. Yes, copy, and here I am just pasting it out somewhere here, and similarly let me paste over here. Yes. Agreed, no? And similarly at -2, definitely the length would be +4 and the direction would be in the direction of positive ay cap. So let me copy this out. Yes. Till this point, at least, each and everything must be clear to all of us. Now I would like to ask one thing. Let's take, you have been sitting somewhere over the 3D space where the y is greater than 0. I have taken the reference of y is greater than 0. I have been at any place over the 3D space where the y is greater than 0. And similarly, I have been at any place over the 3D space where the value of y was negative. I am not focusing over the value of x and z. Now tell me, if you have been sitting over a region where the y is lesser than 0, may I know what is the behavior of the divergence? Whether the field is getting sourced at this point or whether the field is getting sinked at this point. And similarly, when we go in the range y greater than 0, let me rub this out, y greater than 0, what about the sourciness or the sinkiness of the field? Tell me, what would be the behavior of the sourciness as well as sinkiness of the field when the y is lesser than 0 as well as y is greater than 0? Whether both of the reasons, the vector is trying to source, or in partially it is going to source and partially it is going to sink. That is what I wanted to ask from each one of you. While you will visualize this problem now, you will get to know when you have been visualizing or we have been analyzing the field when the y is lesser than 0, you can see very well. Sourced for yes. The answer have started coming. See what is happening over here. You can see very well here towards the region y lesser than 0. The higher magnitude is going inside this point and the lesser magnitude is leaving from this point. What does that mean of it? That means throughout the range where the y is less than 0, by default the behavior of the divergence is sinking. So here it is going to be sinking. And anyways, which we have been discussing in the last class, whenever you have the behavior of the vector field which is sinking in nature, the value of divergence at that region would always be negative. Yes, my dear friends. Similarly, if we'll go ahead with the region y greater than 0, now you yourself are commenting so many things. Yes sir, in this region at least the small magnitude is going inside this point and the higher magnitude is leaving from this point. That means the behavior of vector field is sourcing in nature. So once we calculate the divergence, definitely the value has to be positive. Yes, theoretically speaking or by visualizing this field, we could get to know when we will calculate the divergence when the y is lesser than 0, the value has to be negative, and y greater than 0, the value has to be positive. Mathematically, we will try to visualize the same thing, whether the mathematical formula is working fine or not. So what I would be doing? I would be calculating the divergence of your vector field y square of ay cap. Many of us who might be seeing the concept of the divergence first time, they need not to have any doubt, because I would be spending around 2 to 3 hours over the concept of the divergence itself. Just I am relating the vector field with the concept of the divergence. Yes. Yes, no? So here it becomes 2 of y, that's it, 2 of y. May I know 2 of y is positive or negative? Now it solely depends on the value of y itself. If y is negative, try to understand this way, if y is negative or the divergence is being calculated within the region when the y is less than 0, by default y, which is a negative value getting multiplied with 2, the worth would be negative, could you understand? And similarly, when the y is greater than 0, you yourself would be able to understand, yes sir, if y is greater than 0, the y would be positive value is getting multiplied with 2, the result would be positive. See, many of us could get the divergence of y square ay cap is equals to of 2 of y, but most of us could not exactly understood the significance of 2 of y. What it says? First, it says the worth of divergence would be decided by of 2 of y. That's the first thing. Secondly, it also indicates the sourciness or the sinkiness would be solely dependent on the value or the polarity of y. If the y is negative, it is going to be synced. You can see towards the y less than 0, and similarly for the y greater than 0, you can see it is sourcing. Agreed, no? Agreed? And now one more important thing. In last few examples which I have taken in the last class, the worth of the divergence was constant. What I am saying, the worth of the divergence was constant. Like I have taken example, probably what I have taken example of y gap. Yes, I have taken in the last class. I have taken the example of y gap. The worth was positive and constant. Anyways, I am not focusing over its polarity, I am just focusing over its magnitude. You can see very well, the magnitude is 1 everywhere. What does that mean of it? That means the behavior of sourciness is constant throughout the length of x, y, z. But here, the behavior of sourciness or sinkiness is depending over the value of y. As the value of y towards the positive value of y, if it increases, the value of sourciness increases. You can see very well why. See, if you are calculating somewhere at this point, the input is 1 and the output is 4, so the difference is going to be 4 minus 1, that's a 3. If you go towards the higher value of y, if you come somewhere here, the magnitude is 3 to the power of 2, that's a 9, minus of 2 to the power of 2, that's a 5. That's a 4. 9 minus 4, that's nothing but the 5. You can see very well, if we say this is 0.1 and if you say this is 0.2, both would be sourcing in nature. Where the sourciness would be more? Would it be at 2? Would it be at 1? You can see yourself here, the input was 1, the output was 4. 4 minus 1, that was 3. But here the output is 9 and here the input is 4. Here it's a 5. And as you will go towards the higher value of y, your behavior of sourciness is continuously increasing. And similarly, the same concept goes towards left hand side. Could you understand? What does that mean by the polarity and what does it mean by the function after getting the divergence? If the things are clear to all of us, just write clear over the live chat, so at least I'll get to know. Such intensively we are trying to understand the concept of the divergence, how far I could reach to your mind. And now I would take a break of 1 minute. Just would be focusing over the live chat. If you guys are having any sort of doubt, which we have studied in this class, last class or last to last class, you can put it over the live chat. I will try to smash those doubts over the live discussion itself. Clear, no? Sachin Naik, thank you dear, big heart to you also. The Vijay Kumar says clear sir. That is what I am saying. Try to be regular in my class, because now I won't do any gimmick sort of thing. Whatever I am teaching, I would be teaching in the coherency. So if you start sitting in my class from the day 1 onwards, each and everything would go like a flow of river. Yes, no? So till this point, probably each and everything must be clear to all of us. Now I would like to ask one more important thing. What do you think about the curling of the vector field over any point over the 3D space? You can take either y less than 0 or you can take y greater than 0. Tell me what would be the curling of this vector field, which has been precisely written as y square ay cap. Would it be a null or would it be a non-null? Obviously it would be null. Why? It would be null. Yes. Why it would be null? You can see very well, as I have been discussing in the last class. If you come over this point or this point, until and unless there is no change in the magnitude towards the left hand side or towards the right hand side, or I can say upside or downside. See, this point is in 3D space. No, my dear friends, you had to understand this thing. This point is in 3D space. If there is any magnitude change in direction of front and back, up and down, in any case there would be a curling force over this point. Like if this magnitude is higher, this magnitude is lesser, definitely there would be a curling in this way. Similarly, if this magnitude is larger and this magnitude is lesser, there would be curling in this way. But here you can see, even if you come out from this plane, still this arrow would be same in magnitude. It would be same in magnitude. So anywhere over the 3D space, if I calculate the curl of this point, sir, whether source and sinkiness only depends on the magnitude, am I right? My dear friends, Divya, Bharat, what I was saying, probably you were not present in the last class. See, until and unless the direction of the vector field is not known, no, you will not be able to know whether the sourciness has been taken place or the sinkiness has been taken place. Now you can see very well, here the direction was well directed, it was going inside to this point and this was leaving from this point. You can see the magnitude was higher and magnitude was lesser, so here the sinkiness has been done. But yes, until and unless the direction is not known, you would not be able to say whether the sourciness has been done or the sinkiness has been done. If you could have been taken another field where the direction could have been the different way. If the direction is from right to left, there this point could have been the point of sourciness. And as I can understand from your chat, whether source and sinkness only depends on the magnitude, am I right? Obviously yes, my dear friends. Obviously yes. Why? Once you calculate the divergence, the resultant used to be a scalar field. That means you are just going to discuss, or you are just going to focus over the magnitude, how much magnitude have come in, how much magnitude have went out. So Divya, probably I could have communicated your doubt very well. If you could understand what I wanted to exactly communicate, you can just write yes. So at least I could get to know, thus yes, I could communicate the things into the proper way. Yes. So if we'll be focusing about the curling of the field, definitely it would be a curl-free vector. Yes. Anyways, I would request to each one of you, be present precisely at 9 p.m. We have started a series on engineering mathematics. At very beginning, I would be focusing over, the vector calculus, and vector calculus probably I would be taking 20 hours for the vector calculus itself. Then only end of the day you would be well acquainted with each and individual tools of the vector calculus. Once you are done with the vector calculus, straight away we will be moving into the next topic, and there I would be discussing about the random variable, random process, PDF, PMF. There are several things where the most of the student fears a lot. I would be discussing in great detail, Yes, till this point probably I could have communicated the things in the proper way, and probably each one of us could have visualized what exactly I wanted to communicate. Yes. So let me move forward. Let me divide this digital board into the two parts. Here goes the division, and I would be taking the next vector field, and I would expect from each one of you that you guys would be able to answer this problem out. Yes, the next problem. Already so many questions we have taken. Let's take the next question is like 1 upon y, a y cap. Deliberately, now the magnitude has been taken reciprocal to the y, because so far whatever the magnitude I was taking, the component of y was coming towards numerator side. That means as the value of y was increasing, the magnitude was getting increased. But deliberately I have brought y towards the denominator side. Agreed, my dear friends, what I am saying? And now this field is valid only for the y in between, let's take 2 to 5. Yes, 0 elsewhere. You can write 0 elsewhere. That means we have a specialized case where the field persists in a limited form of version within the y is equals to 2 to 5. Obviously x could be minus infinity to plus infinity, z could be minus infinity to plus infinity, whereas the field is 0 elsewhere. I wanted to know what would be the behavior of find the, let's take the vector is being written as a vector, find the divergence of the a vector. That is the first important case which we had to deal. Let's take at y is equals to 4. Y is equals to 4 in between 2 and 5. Yes, and similarly I need to get the value of curl again at y is equals to 4. which falls in between 2 to 5. 2 to 5. Tell me, what would be the worth of source, what would be the worth of del? Anyways, nobody should use the mathematical formula which we use for getting the divergence. I would expect from each one of you, first, figure it out how the 1 upon y, ay cap would look like in Cartesian coordinate system in 3D space. Once you're done with that, try to understand whether the sourciness or the sinkiness of the field has been taken place. Once you're done with this, now you can figure it out whether any curling or rotational force is being experienced by the point at y is equals to 4 or not. Y is equals to 4 or not. I would like to get the answer from each one of you. I would like to get the answer from each one of you. Yes, tell me, what would be the best most answer for this particular structure? My dear friends, so what I would be doing, as I have been doing so far, I would be taking a Cartesian coordinate system. As I have been taking this coordinate system as a y-axis, this has been taken as a z-axis, and now here goes the x-axis, which is vertically out from this plane, Yes. Now, as it has been clearly given, the vector field exists in between 2 to 5, and the magnitude or the worth of the vector field is simply 0 beyond y is equals to 2 and similarly beyond y is equals to 5. So, I would be taking the reference of y is equals to 2 as well as 5. Let me take that. So, here it goes y is equals to 2, yes, and here it goes somewhere y is equals to 5. So, I have taken the limits in terms of y is equals to 2, y is equals to 2, and here goes y is equals to 5. Yes. Sir, what was curl of last question? Yes, the curl is simply 0, no, my dear friends. The curl is simply going to be 0. So, the one doubt I have got it from Sachin Nayak. The Sachin Nayak says, what's going to be the curl of this problem? Obviously, the curl is going to be 0. How the curl is going to be 0? You can see very well at this point or at this point, there is no parallel vectors which had the difference in magnitude. If it is not happening, what does it mean of it? Which we have seen in earlier case, if ay cap consists of only and only function of y, by default the curl has to be 0. Anyways, why don't we write over here, if we talk about the curl of this vector field, that is being written as del cross a vector, that's nothing but y square of ay cap. So, with the help of determinant, you would be able to easily get the result, and that's simply going to be 0. Yes, that's simply going to be 0. So, now I would expect from each one of you, try to figure it out, how would be the result? Tell me. Tell me, how will we draw this particular vector field? So, what I would be doing, here I would take 3, then 4, then 5. Yes, for the better clarification, why don't we take y is equals to 3 and here goes y is equals to 4 and there it goes y is equals to 5. You can see very well at y is equals to 2, it's simply going to be 1 upon 2, the magnitude is going to be 1 upon 2. At y is equals to 3, y is equals to 3, the magnitude is going to be 1 upon 3. At y is equals to 4, the magnitude is going to be 1 upon 4. What does that mean of it? As we move towards the positive value of y, the magnitude keeps shrinking and still the direction used to be in the direction of positive ay cap. Why? Because I have considered only positive value of y, that means 1 upon y would always be positive, and once 1 upon y is always been positive, definitely direction would be in the direction of positive ay cap. Agreed? So, what I would be doing at very beginning, let me start with what should I be doing over here. Let me take the different way. Yes. Now, what I would be doing over here, just a minute. Now, you can see very well at y is equals to 2, anyways towards left hand side the magnitude is simply 0, but at y is equals to 2 the magnitude would be highest. Yes, it would be highest. And as the y is equals to 3 comes, the magnitude would become smaller. It would become smaller. Yes. And as I go towards 4 even, the magnitude would become more smaller. Just a minute. I can take this. Yes, it would become more smaller. You can see by yourself. Let me do one thing. Let me complete this out. Sort of this. Yes, here it is larger. Here it is smaller. Here it is more smaller. Here it is more smaller. Tell me, what would be the behavior over here? Now, if I wanted to know the sourciness or the sinkiness of the vector field at any point over the range 2 as well as 4. Tell me, what would be the behavior of the sourciness or the sinkiness or the divergence? Would it be sourcing or would it be sinking? Or exactly at y is equals to 4, what would be the behavior? Would it be sinking in nature? Would it be sourcing in nature? I want the answer from each one of you, and nobody should use the mathematical formula to get the divergence for this given vector field, because from the mathematics definitely you would be getting the answer, but physically you are not able to understand the actual significance of the vector field and the concept of the divergence, where we discuss about the sourciness as well as sinkiness. Now definitely the answer have started coming. The Sachin Nayak says it's gonna be sinkiness. It's going to sink. Obviously it's going to sink. Now even from the divergence you can get the same answer. If you calculate the divergence of your vector field, which has been written as A vector, how did we calculate this? You can see very well, it has got the component in the direction of ay cap alone. So first partial differentiation which takes place of the component in the direction of x, which is simply 0. Now the second component or the component in the direction of y gets partially differentiated with respect to the y, which is equals to 1 upon y, and similarly it goes with the z, which is simply 0. Agreed? And the result which we get, it's simply going to be 0, and here the value which we are getting, the partial differentiation of y to the power of minus 1 is simply going to be minus 1 divided by of y square. And now you can keep y anything in between 2 to 5, and here I had to pick the value y is equals to 4. And you can see very well the answer has been minus, and that to 1 upon 16. Could you understand what was the outcome? Yes, because of the differentiation also, the minus sign have come out, and because of the minus sign you can see whatever the theoretically we are calculating the things, even mathematically it seems to be very same. Yes, no? It is been very same. Such a intense calculation must have been worked the person who have given the concept of divergence. See how he could figure it out, the field, the sourciness as well as sinkiness of the field, and how he could have converted the concept of the sourciness as well as sinkiness of the field with the help of mathematical formula. And yes, we are just enjoying the mathematical formula. We are just getting 2 marks by using this mathematical formula without knowing its background itself. Tell me, still the divergence is not yet over. As I said, I would give around 2 to 3 hours only over the concept of the divergence, just to give the actual crux of the divergence. And once you are done with the divergence, nobody is going to leave any problem related to the closed surface integral. Repeatedly problem do come from that segment, and even in ECE this year one problem have come from that concept. So I would like to get the hard shape from each one of you, not for me, for the person who have invented the concept of the divergence. I am the person who have just learned what does it mean by the divergence, but the person was the real gem who have invented the concept of the divergence. Yes, this much theoretical understanding have gone till mathematics. Not only that, my dear friends, you can see very well, as the value of y would increase, the magnitude would start decreasing. Yes, the minus would be there, but as the value of y would increase, no, the magnitude would be start decreasing. Why? Because you can see at very beginning there was a large difference between the incomer and outgoer magnitude, but as you would be prevailing towards a positive value of y, what would happen? The amount of magnitude which is coming inside the dot and the amount of magnitude which is leaving from the dot would be continuously decreasing, Still I am saying there are a lot to speak about the divergence. But this is not the time to talk that much about the divergence. But my dear friends, now the people say, sir, we find this subject difficult, we find divergence and curl non-significance, just we calculate the divergence as well as curl, but exactly we do not get the actual crux of the divergence as well as curl. Now this is the right time. You could have figured it out little bit about the divergence as well as curl. Few of the important thing, whenever we calculate the divergence, always the divergence is being applied over the vector quantity. That's the first thing. Why the scalar quantity, the divergence cannot be calculated, which we have seen in the last class. Until and unless the direction is not known, no, you will not be able to understand whether the magnitude which was larger was coming towards inside this dot or whether it was leaving from this dot. Yes, so divergence would always be applied over the vector quantity. And end of the day, once the divergence is applied, no, the result would always be a scalar quantity, because it is just talking about whether it was sourcing certain amount of flux or whether it is sinking certain amount of flux. Sir, we want to learn in depth during engineering. I lost my interest in maths. Mayank, just wanted to ask one thing, whether really you are enjoying these lectures or not. Just wanted to know from you. And as I know, I can go on speak about the divergence and curl, but that's not important for you guys. I would just be restricting myself till this point. Yes. And now that's a good amount of time I have spent over the divergence. Why don't we start with the curl also? If I take the curl of this vector field, which is 1 upon y, ay cap, I would like to get the answer from each one of you. What do you expect? Sir, we have, okay. What do you expect? The value has to be a null vector or whether it has to be a non-null vector? Obviously, it has to be a null vector. Even you yourself once come to this point, you would not be experiencing any rotational force. That means there would not be any curl at all. Anyways, nobody should write this result as 0. It has to be 0 vector. Because I have seen many of the times the student do mistake over this point. 0. Once you say 0, that means you are talking the magnitude is 0 in scalar domain. And once you call null vector or 0 over the 0 vector, that means the result is gonna be null, but yes, it is a sort of vector. Yes. Could you figure it out? So probably till this point, you could have figured it out, the basic concept of the divergence. Now, I would go ahead with the next example, and there we would try to understand the basic concept of the gradient. Tell me if you know a bit about the gradient. Anyways, I am not jumping into the complete concept of the gradient, because I would be taking around 2 to 3 hours. I would be just focusing over the gradient for the 2 to 3 hours. So anyways, keep aside the gradient for the time being, but still with the help of a scalar field, I would try to smell about the gradient. Yes. So let me bifurcate this page into the two parts. Yes. Agreed? Now tell me, I wanted to ask few of the questions, and I want the answer from each one of you, from the people who have been attending my class live, and I can see over the live chat around 12 or 13 number of students are live. The first question I would ask, like the gradient, whether it is applied over the scalar field or the vector field. If answer is scalar, you should write 1 and then scalar, and if the answer is vector, you should write 1 then vector. That's the first question I would like to ask from each one of you. Similarly, the second question goes like, if the gradient is being applied on valid field that you had to decide whether it's a scalar or vector. So the result, would it be a scalar field or would it be a vector field? If the result is a scalar field, you should write 2 then scalar, and if the result is a vector field, you should write 2 and vector, 2 and vector. Yes. Anyways, let me give a brief idea about the gradient. The gradient is being applied over the scalar quantity and it results the vector quantity. Now the one thing comes in mind, sir, how the scalar field can be converted into the vector field? And so far, the different kinds of the field which you have drawn over the Cartesian coordinate system were the vector coordinate system, vector field. But how will you draw the scalar field over the Cartesian coordinate system, or for the time being any coordinate system? Yes, the answer have started coming. So the 1 is scalar and 2 is vector. Obviously yes. Yes. Now let me have a little bit glimpse about the gradient. First, the gradient would always be applied. The gradient would always be applied over the scalar field. I may write this as B. Now many of the students would have the doubt, sir, what does it mean by the vector field and what does it mean by the scalar field? My dear friends, whenever I say field, by default it is mere a function. And if I say scalar field, that means it would be a scalar function, and similarly whenever I say vector field, it's gonna be a vector function. What does that mean of it? It would be a function of x, y and z, and it would also have the direction. So now the gradient has to be applied over the B, and the vector has not been applied over the B. That means B is a scalar field. And the result which I am getting, let's take for the time being, I may write this as a vector. Anyways, this is not the right time to speak about the gradient into the great detail. The lectures are yet to come where I would be discussing about the gradient. I would be taking up plenty amount of the questions from previous year question, and end of the day you would be more than thorough over the gradient, because the gradient is a very important tool which are used for many important purposes like directional derivative. Yes, the gradient is used for calculation of directional derivative of any scalar field. It is used for drawing the normal over a certain plane. There are several usage of the gradient, but that would be seen once the gradient starts. Yes, could you understand? Sir, when will the EMFT for the GATE 2020 start in live app? Very soon. Yes, no. Next thing comes in mind, my dear friends. Let me take a scalar field. For the time being, the scalar field which I have taken, no, it's a B is equals to of merely. So far I have been taking Y again and again. Now it's the right time to take, let's take Z. So each one of us are very clear. If B has been taken as Z, that means the B has been the function of x, y, z. It has been the function of Cartesian numbers. It could be r theta phi, it could be rho phi z. But yes, the direction has not been attached along with this factor Z. That means the B is going to be a scalar field. Till this point, nobody should have any doubt. Now, so far, when I was drawing the vector field over the Cartesian coordinate system, we have taken the help of arrow. The arrow had got its length, the arrow had got its direction, but here I won't have any direction because it has been a scalar field. It would have only and only magnitude, and that is why rather taking arrow, I would be taking what? I would be taking circle, and the radius of circle would decide the magnitude of the given scalar magnitude at the given position. Agreed? So let me take the reference of, again I would be doing the same procedure. Let me take the reference of Cartesian coordinate system. The x-axis would come out. Just a minute. The x-axis would come out. Here goes my positive z-axis. Here goes my positive, just a minute, y-axis, and here goes my positive x-axis. And now if you will be focusing over B is equals to Z, what does that mean of it? That means the magnitude would be continuously increasing. But I am saying the magnitude would be continuously increasing as the value of Z is increasing. And now you can see very well the B is equals to Z would be valid only for Z greater than equals to of 0, because the magnitude can't be negative. Even it can be negative. I am not sure. It can't be positive or negative. For the time being, you can take an example. No? Like here the AC is running. So the temperature profile has been maintained within this room. and the temperature is going to be a scalar quantity. So obviously temperature over here, over here, over here, over here near to AC would be the function of x, y, z. And as the temperature being a scalar function, definitely the temperature profile within this room would make a scalar field, which would be the function of x, y and z, and even its magnitude could be positive as well as negative. Like if AC is running with the full throw, even the temperature inside the AC might have gone lower than 0 degree. So this word could also be negative. But for sake of better understanding, I have taken the situation when the z is greater than or equals to of 0, and I have been dealing with the positive value of z, and yes, the magnitude would always be positive. So what I would be doing over here, at very beginning I would start with b is equals to of z, and over y axis the value of z is simply 0, and as the z is equals to 0, you would be having a circle with the radius is equals to 0, which is just a merely point. So here goes the points. Yes, no? And as you go upside, let me take few references, just a minute. As you go upside, let's take, you have gone to z is equals to 1, you have gone to z is equals to 2, you've gone to the z is equals to 3, yes. Now what would happen? The magnitude has to increase, at z is equals to 1, of 1, you would be having a circle with the radius is equals to of 1, just a minute, copy, yes, like this, yes, like this. And as you would go towards z is equals to 1, here it was z is equals to of 1, and here it is z is equals to 2. Definitely the magnitude is increasing, and as the magnitude is increasing, the radius of the circle would increase. EQ temperature surface, obviously, the same concept as I have been communicating. I would be taking the problem from the electrical, electronics and instrumentation segment, and even I would be taking the problem from the mechanical as well as civil. So be confident about the vector calculus. I am going to take the each and individual things, yes, because when I was there in BARC, so the MTech was done in BARC itself, I had around 8 to 9 subjects from mechanical and 2 subjects from the civil. So I have a bit idea about the mechanical as well as civil. I will try to correlate those all concepts while I would be teaching over the vector calculus. Yes, I would take the experience of those all inputs. Now what would be the case now if I would be reaching over here? Now the radius of the circle would increase a bit. Yes. Now I can copy this out. Just a minute. Yes, and now if you reach at z is equals to of 3, the magnitude would be even increased, So here it goes like, I can take the white circle, yes, Now would like to ask one thing from each one of you, what the gradient does. So whenever you calculate the gradient, obviously the result is going to be a vector field, but I am saying whenever you calculate the gradient, that means the gradient of V has been written as del of B, the result is being written as A vector, and the A vector would have the two parts. What are they? They would have its magnitude and it would have its direction. So once you focus over its magnitude, how do we calculate the magnitude? Simply you can calculate the magnitude of A, and once you calculate its direction, the direction would be in the direction of A vector divided by of mod of A. Or you can simply write it's a unit vector in the direction of A vector, which is simply equals to of AA cap. May I know, would like to ask from each one of you, what the magnitude states and what's the direction it states? My dear friends, the magnitude indicates maximum rate of maximum rate of increment, or maximum rate of change, you can say, because the increment and decrement is subjected to the direction. If you are like if you are coming away from the AC, the temperature would be increasing, and as you will be going near to the AC, definitely temperature would start decreasing. So I would just be focusing over the magnitude. The magnitude indicates the maximum rate of change, yes. And similarly here, the direction would always be in the direction of, maximum rate of increment, maximum rate of increment. That means the direction at which the maximum rate of increment in a scalar field has been taken place. So now I would like to ask from each one of you the scalar field which I have taken for the sake of reference, which is nothing but the B is equals to of Z. May I know which path I had to be taken, which path I had to take for getting the maximum rate of increment? I would try to get the answer from each one of you. Tell me what path has to be taken, to get the maximum rate of increment in a scalar field Z, and the scalar field is clearly drawn over this Cartesian coordinate system. Tell me, I want the answer from each one of you. My dear friends, obviously the path has to be vertically up. Why? Because you can see very well, if you are going vertically up without spending much distance, you are keep changing, or at the fast speed you keep changing or keep increasing the magnitude. Yes. That means in future, if you will get the gradient of the scalar field Z, if you will calculate the gradient of a scalar field Z, my dear friends, and then you will get the direction of the gradient, you will get to know the value is going to be plus a Z cap. You can calculate by yourself. So the gradient has to be calculated for the scalar field which is simply equals to of Z. How do we calculate this? Simply the scalar field has to get differentiated with respect to the x, and this factor would become the component in the direction of x. Then here it goes the partial differentiation with respect to the y, ay cap, and here it goes az cap, and you can see very well this goes off, and the result which have come out, it's simply plus az cap. Obviously it is a vector quantity. It's a vector quantity of gradient of the scalar field B. Now you can have its magnitude as well as direction. What's going to be the magnitude? Being a unit vector, the magnitude is simply going to be 1. If you would be focusing over its magnitude, the magnitude is simply going to be 1. Once you're done with its magnitude, if you'll be discussing about its direction, obviously this vector has to get divided by its magnitude. It gets divided with the 1. By default, it's going to be plus of az cap. And you can see very well, if you will be discussing about the direction of the gradient of V, the value has been plus of az cap. Yes. Could you see the same thing is happening along with the graphical understanding? Yes, my dear friends. Now I would ask one thing from each one of you. Now I would change my scalar field a bit. And rather taking gradient of B, I have designed a new scalar field, and let's take the new scalar field is 1 upon Z. Tell me what would be the direction, or what would be the unit vector in the direction of gradient of 1 upon Z. Would it be at plus az cap? Would it be at minus az cap? Would it be at plus ax cap? Would it be at minus ax cap? Would it be at plus ay cap? Would it be at minus ay cap? Tell me what would be the answer over here. Now you can see very well, it is being a scalar quantity. What does that mean of it? That means the significance is quite self-explanatory. It won't have any direction. And as it do not have any direction, so once I would draw over the Cartesian coordinate system, I would not use the arrow which I have been using so far for the vector field. I would just be using the circles. May I know where the circles would be larger? Here the circle would be larger. Hypothetically speaking, here the circle radius would be infinity, and as I would be moving up definitely the radius of the circle would start shrinking. The radius of the circle would start shrinking. And now if you'll say, what is the direction of maximum increment over the scalar field, you yourself would be able to understand. Now it is down over the side. Now you yourself would be able to understand. Obviously, Anand Gaurav, could you understand what exactly I wanted to say? Here it would be a larger radius, here it would be a smaller radius, and here it would be a smallest radius as you go upside. Anyways, as I have been communicated earlier, whenever we discuss about the direction of any scalar field, if we take its gradient, the direction used to be the direction in which the maximum rate of increment has been taken place. So obviously the increment has been taken place in this direction, which is the direction of minus Az cap, which is the direction of minus Az cap. Minus Az cap. So you can calculate this. Once you will calculate the gradient of 1 upon Z, the process would be almost same. You will take the partial differentiation of Z inverse, which would be equals to of minus 1 divided by of Z square of Az cap. Depending of the value of Z, the magnitude would get decided, but once you will calculate its direction, the direction would always be in the direction of minus Az cap. So if you calculate unit vector, you will get to know it's always in the direction of minus Az cap. It's always in the direction of minus Az cap. Agreed node? Yes. Agreed node here. And here the magnitude you need not worry about it. The magnitude would be dealt when I would be going into the detailed concept of gradient. Obviously minus of Az cap. Anyways, I would try to bind up my video here itself. Just wanted to ask, should I change my way of teaching? Because yes, we are going to spend around 20 to 30 days over the series of mathematics, where my basic understanding was to cover vector at very first, and once the vector is done, I would be covering the PDF, PMF, probability density function, probability mass function. I know practically you do not feel actual crux of that. That is why I have planned to take that. Should I change my way of teaching? Should I be going a little bit fast, or each and everything is very, very comfortable in your zone? So I wanted to take the feedback from each one of you. If I should increase my speed, you should write I. If I should decrease my speed, probably decrease would not be the suggestible by any of one. That's D. And if each and everything is okay, you can just write okay. The same speed I would be following in next video. Saurabh Bhandari, comfortable sir? No, comfortable. Yes. I want the input from each one of you, otherwise unnecessarily I may change my mode of or speed of communication, which would be hearted to most of us. Tell me, okay then, what about the quality of video? My dear friends, only 10 students are watching this video. Comfortable and perfect, sir. Thank you, dear. And very less number of viewers are there over the concurrent viewers. I would expect more viewers. So at least try to communicate to your batchmates, to your seniors, to your juniors, if you really finding this video very much beneficial. And I know definitely this video is very much beneficial, because you are learning the basic crux of the individual important tools which we use in vector calculus by heartedly. Okay then. Almost all are comfortable with this speed, so definitely we would move ahead with this speed alone in future. And yes, as I have been communicating, my span of lecture would be 1 hour, which will start from 9 and would last till 10. Sir, 66 mark in mechanical paper 1 OBC, any chance for IITs? Anyways, for that I need to draw, or I need to take another session. Anyways, I would not comment anything at least this moment of time. Sachin, all the very best. Anyways, we will meet with the same pace as well as same agenda, where I would be going into the deep analysis. I would say the deep learning of the vector calculus exactly tomorrow at 9 PM till 10 PM. Bye-bye. Take care. Sabak khair.